We have 3 methods to solve a system problem, okay? But sometimes one method is much quicker and easier done, so you need to be able to make the choice, okay? Right now, what I'm gonna do though is I'm gonna force us to use all 3, no matter how much work it takes for each one. Does that make sense? Okay, so I want you to work each one with me, but I want us to be able to look at the big picture at the end. What did we do to do all 3? And then choose the most effective method to get it done. Does that make sense? Okay, so here we go. The first is graphing. What do we need to do to be able to graph these 2 equations? Y equals mx plus b. So immediately what I'm going to do is I'm going to go in and I'm going to change these to y equals mx plus b. And I'm going to box them in. And you should be able to do that naturally. If not, there's a page in your notes and an anchor chart to show you. The second one, I'm going to do the same thing. Take that x and squinch it to the other side. Divide by the -2. Yes, I'm going fast because you already know how to do this. You can slow it up when you're doing your problem. So I got them in y equals mx plus b. So what do? Graph them. So this is what I did. Now this one was kind of easy because the y-intercept was the same for both. So I knew that that was my intersection point and I wrote my coordinate. When is this a good method? When is this a good method to choose? What do you have to have? A graph. So if you don't have a graph, you can't do this method. And why go through all this? You can just go straight into the algebra. So when is this a good method to do? When they're both in y equals mx plus b to start. You don't want to have to do all this math. There's no point in it. You can go straight. This is not an accurate way to do it. Do we make a lot of mistakes when we graph? Yes. And so you need an accurate way. Now substitution. We have the same 2. What do we have to do for substitution? What do we have to do? We have to pick the equation that we can isolate easy. So which one is it? The top one. Because remember, if one of them does not have a coefficient, that's going to be easy to change. So this one is going to become y equals 6x plus 6. So that means I take this and I plug it in for y. And I rewrite my equation. Now, at that point, I'm just going to solve. So I'm going to go in quick and I'm going to solve it, okay? Box it in. Does this match that? Yes. Look. The x is both zeros. So now what do I do with this x, guys? I go to the circled equation and I plug it in. And look, it matches. So I write my coordinate. Did I get the same answer? Yes. 2 completely different ways to get there. So then I go to elimination and I've got my problem. Are they lined up? Yes. Do I see an inverse pair? Yes. Do I add them or subtract them? Add them. This cancels. 1 plus -2 is -y. 6 plus -12 is -6. But remember, I got to divide by the -1 to isolate it. Did that match? Yes. So I plug this into the bottom equation. (6x minus 12 equals -12). Add the 12. 0 equals 6x. X equals 0. Did it match? Yes, I got the same answer. Now, which one do you think was the most streamlined? Was there that much difference between these two?
No.
Not on this one, because it was easy to change to y equals mx plus b. But if you see elimination easier, then I would go there. And to be honest with you, they're both in standard form and are lined up. So which one would have been the most efficient for this one? Elimination. Very good, Nick. Because they are already lined up and you see an inverse pair. Okay, so you can cut the video.